Okay, hello again, folks. Let's try another one of these online videos. Hopefully this one works. We are going to continue chapter 4. We've looked at free fall. We looked last video at ramps. Remember, ramps were all about gravity, or acceleration, I should say, not being equal to 9.8 meters per second squared. It's something less than that. Today we're going to look at pendulums. And we've seen pendulums. We've done labs with pendulums before. We had washers tied on the end of a string. I just really quickly want to go over a couple of things that do matter for pendulums and a couple of things that actually don't matter. So we are talking about pendulums, and here it says period. Remember, period is the amount of time it takes for one cycle to occur. The symbol for a period is a capital T, and a one cycle is there and back. So if you have this pendulum, these washers on the end of a string swinging, you let them swing there, and you let them swing back, that would be equal to, that amount of time would be equal to the period. So it's the time to do one there and back, one tick and talk if you're a clock. Yo. Rhyme skills. Here's a couple of things that the period does depend on. So what kind of things about a pendulum would impact the amount of time it takes to swing there and back? Two items actually do. It turns out that the length of your pendulum matters. And you may recall when we looked at the period of a pendulum lab, I guess months ago now, you might remember that the long pendulums swung nice and slowly. And then as we made the pendulum shorter and shorter, they started to swing back and forth quite quickly. And it was a bit trickier to time them. So the length definitely had an impact on the period. And so does gravity. So where gravity is stronger, the pendulum will swing faster. And if we went up to the moon and we played around with pendulums, gravity on the moon is about 6 times smaller than it is here on planet Earth. So your pendulum would swing about 6 times slower. Be kind of weird. So that are those are the factors that do impact the period of a pendulum. And there's a couple of things that actually don't matter. What doesn't really matter, and both of these should have little asterisks beside them, is amplitude. So that means the size of your swing. Amplitude doesn't matter as long as your swings are small. You might remember we talked about that in the lab as well. We said swings of usually less than 10 degrees from vertical were optimal. And the other thing that doesn't really matter is the mass that's attached to the end of the string. But the mass on the end of the string has to be much larger than the string itself. So that's why we had gone with 2 washers, and then I found some really fine thread. That way the mass of the washers was much more massive than the thread itself. So our pendulum worked well. You couldn't tie 2 little washers onto the end of a really thick piece of rope, because then the mass hanging on the end is not very big compared to the mass of the string itself, and your pendulum wouldn't function very well. So there's your assumptions that the swings are less than 10 degrees and the string is basically massless compared to the thing hanging on the end. Those assumptions aren't a huge deal. You can write them down or not. Here's what is important. Length and gravity, we know, impact the period of a pendulum. So what's the equation we're going to use to find the period of a pendulum? Well, it involves those 2 things and pi. Everybody likes pi. So the period for a pendulum is equal to 2 times pi times the square root of the length of your pendulum divided by g, which for the most part for anything on Earth will be 9.8, but we could go in a question to some other planet and play around. So let's try out a couple of questions using that equation. It's really not that bad to work with. Sometimes you'll be asked just to solve for period using that equation, which is really nice because it's already isolated for period. T is already by itself. And then we'll look at one example where we have to just play around with some algebra and maybe isolate something else out of that, like the L is another common one to have to find. But we'll start out with one that's easy. Let's look at a couple of questions where we assume gravity is 9.8. In this case, just like ramps, let me scroll back actually. Since we're taking the square root of L divided by G, And your calculator will get angry. You've probably tried this. Your calculator will get angry if you try to take the square root of a negative number. Just like in ramps, where we left gravity as a positive 9.8, we have to do the same thing with pendulums, because we can't square root negatives very nicely. So G will be a positive 9.8 for pendulums as well. So let's try this example. Let's find the period if the length of your pendulum is 2.2 meters. So this one should be pretty darn straightforward. Plug the values into that equation that you just wrote down. T equals 2 pi times the square root of 2.2 divided by 9.8. Just some calculator work now. Do make sure that you're using the pi button on your calculator, not just 3.14. And when you go and you run those numbers, trust that you can do it. That's not important. It's easy. You get 2.98. You could call that 2.98 seconds or 3.0 seconds. We hit our 2 or 3 sig figs. Done. So if you have to use that equation and you are trying to solve for the period, it's pretty darn easy. The only thing I would say is just make sure that the length of your pendulum is in meters. Because if you had a short pendulum that was in centimeters, you would have to catch that conversion. This equation here worked great if your length is in meters, but it's not going to work very nicely if it's in centimeters or millimeters. So do convert into meters if you need to, and then hit the calculator. Done. Let's try this one. Find the length if the period is 2 seconds. So we're going to have to do a little bit of algebra on this one, and I'll do this one by hand with you. So the equation was T equals 2 pi root L over G. And here we actually know the period is 2 seconds. So 2 equals 2 pi root, we're looking for L. We know G is positive 9.8. Now, algebraically, the first thing you're going to want to do, sometimes people will try squaring things. I wouldn't go that route. The first thing I would do algebraically in this question is I would divide by 2 pi. Now, you have to be a little bit careful, and I've been harping on you about this all semester long, and most people are, I think, becoming trained in catching it. You have to be a little bit cautious when you type that in your calculator. Hopefully you can see mine here. If I try dividing 2 divided by 2 times pi, I think some of you are going to know what happens there. We run into a BEDMAS issue where 2 divided by 2 is 1 times pi equals pi. But that's not actually what we want to have happen here. We want 2 times pi to happen first, and then we take whatever that value is, and that's the division. So you have to divide. When you do the 2 pi, you have to put the 2 pi in brackets. And again, that has come up over and over and over again in the course. So 2 divided by, and this catches people with this kind of question all the time. 2 divided by, open the bracket, 2 times pi, close the bracket. There's the number we're looking for, 0.3183. 0.3183. That is now equal to root L over 9.8. Now you could go ahead and square both sides. And by squaring the right-hand side, that's going to cancel out with the square root. I'm actually just going to leave, if you guys are okay with this, I'm going to leave that as just 0.3183 squared, instead of figuring out what it is. Let my calculator do it at the end. And then we're simply going to multiply by 9.8. And that's going to give us a length in meters. I'll even use my answer button here. So the answer squared, 0.3183 squared times 9.8. Looks like it's 0.993 meters. Now, I want you to think about what we just did for a moment. We found the length for a pendulum that has a period of 2 seconds. So if you think about that, what does that actually mean? Well, a period of 2 seconds means it took 2 seconds to swing there and back. So you actually just found the length of a pendulum that takes 1 second to swing in one direction and then 1 second to swing back. And some of you are going, oh, I know what that is. You actually just found the length of a grandfather clock, which is kind of cool. So I don't know if people have seen these things before. I don't mean to offend anybody, but they're called grandfather clocks because I think they're kind of favored by old people. I don't know that too many people your age are rushing out to buy a grandfather clock. But if you wanted this thing to keep time accurately, you would need to make sure that the pendulum inside is exactly, let's go back to that number, 0.993 meters. In fact, you'd want it to be that many meters. So very, very careful measuring of the length of the pendulum inside a grandfather clock. There you go. It's just shy of 1 meter in there. So that's kind of a neat calculation, a neat thing to know. Scroll through that. Okay, so just like we did with ramps, just like we did with free fall, let's talk about using pendulums to find gravity. What if you ended up on another planet and like, hey, physics, maybe we will. What if you ended up on another planet with string and some washers and you wanted to figure out what's gravity on that planet or on this moon? We can do that, and I would assume that you guys could look at that equation that we just used, T equals 2 pi root L over G. Since half of the questions you look at are going to be using pendulums to find gravity, wouldn't it be nice if we had that equation rearranged so that it was G equals instead of having it as T equals? And what I'd like to do with you right now, if it's okay, is let's go ahead and figure out what the algebra looks like to isolate the G. And then that way you can always just use that equation if you want to find gravity with pendulums. So if we're going to try to get G out of there, the first thing we'd want to do is divide both sides by 2 pi. That's going to cancel the 2 pi, so that leaves us with T divided by 2 pi equals root L over G. And then we would want to square both sides. And what's kind of weird is when we square like that left-hand side, we actually square everything there. So the T gets squared, the 2 gets squared, and the pi gets squared. And then over on the right-hand side, it just cancels out the square root sign. So we're left with T squared over 4 pi squared, because 2 squared is 4, pi squared is pi squared, equals L over G. We can cross multiply. Maybe I'll show that. So we're going to multiply diagonally. That leaves us with, sorry about that, GT squared equals 4 pi squared L. And if we want to isolate the G, we're one division away. Divide by T squared. So here's a really great equation that you guys can use. It's on the formula sheet actually, but this is the equation that you can use to find G using pendulums. G equals 4 pi squared L all over T squared. Now, you don't have to derive this equation for me again. We did that just so I could show you that this equation that we just solved for is that equation. Those two things are actually exactly the same. They're just rearranged to solve for different variables. So let's try out a question using this newfound equation where we've got some information about a pendulum and we're trying to find gravity. So we'll scroll through all that. There it is. So let's try this out. 235 centimeter pendulum makes 15 cycles in 46.1 seconds. We are asked to find G. And you look at that and you say, okay, we're talking pendulums and we're finding G. Let's use the equation that we just came up with. G equals 4 pi squared L all over T squared. Now we have a couple of issues in this question that hopefully you can recognize. One of those issues is a unit. Remember that we as physicists like to measure in meters. So that's not going to work. 235 centimeters is going to be 2.35 meters. So we're going to have to catch that. So let's go ahead and plug that into the equation. 4 pi squared times 2.35 all divided by. Now we have another issue here, and that is period. Remember, you have to have a little bit of an understanding about what period is. Period was the amount of time to complete one cycle. And here, this question gave us the amount of time to complete 15 cycles, which is not really what we're looking for. So we're going to have to do a separate calculation off on the side here to figure out the period. Now on your formula sheet, you maybe haven't used these for a while, and I think they're like the very first equations on your formula sheet. There are equations for frequency and period. And you'll find that there's one that says period is equal to time divided by number of cycles. So we can plug in the information that we've got in this question. You probably could have figured it out without going to the formula sheet as well. I have no doubt you guys are smart. So this is 46.1 seconds to complete 15 cycles. If we divide those two values, that's going to give us the time to complete one cycle. I have no idea what that is. Let's try it out. 46.1 divided by 15. There you go. 3.07 and a bunch of threes. 07. And I'm going to pull some extra sig figs here just so I don't end up with rounding issues. So that's the period. That's the amount of time for one cycle. And now I can take that value and I can plug it into the t squared. Don't forget to square it. That's going to be the denominator of this equation. And that extra calculation we did right here to find the period first, that's classic physics 11. Almost every time you need to use the equation G equals 4 pi squared L over T squared, almost every time you're going to have to find T. I will give you the amount of time for more than one cycle and you'll have to do a little division. So pretty classic physics 11 question there. From this point it's just calculator work. 4 times pi squared times L divided by, I'm going to use my answer button, pull all those sig figs from the period squared. There you go, 9.82. And remember, you want these things to be like 9.8-ish. 9.82 meters per second squared. Because we use positive G's with pendulums, I am perfectly fine if you leave that as a positive value. If you'd rather switch it to a negative, that's totally fine too. So there's pendulums. I don't think you'll find that too bad at all. The practice, the homework, is worksheet 1, and you'll find this on the chapter outline. Worksheet 1, we're on numbers 13 through 18. And I'll pull those up. I think I've got them open here. Yeah, there they are. So this is worksheet 1 that we've been plugging away at. Should have done up to 12 for the last video. Now we're into the pendulum section, 13 through 18. And I don't know if I did this on your guys's already. If I didn't, I apologize. But you'll notice there's some uncertainty with 16, at least on my version. I think I took it out on yours. If not, just take that plus minus out. We're not going to do uncertainty. You can still do the question, Just don't worry about the plus minus on there. So there's your homework, the practice that goes with the pendulum lesson. If you have any questions about that, fire me an email or check in with me at the next Zoom meeting. Until then, take care.